The drug we are going to discuss today is acetazolamide. Acetazolamide is a non-bacteriostatic sulfonamide that lacks the antibiotic activity. It is used as a carbonic anhydrase inhibitor and a diuretic too, but a weak one. It was developed by Laddeley's laboratories and came into medicinal use in 1952, but at present considered as an essential medicine by WHO. Chemically, it is known as 5-acetamide 1,3,4-thiodiazole-2-sulfonamide with a molecular mass of 2 to 2.24 gram per mole. It can be given orally with or without having food or through IV route. IM preparations are not recommended. The doses available for this drug are tablets, powder for the injection, and sustained release capsules. Now, let's jump toward the pharmacology of acetazolamide. The function of carbonic anhydrase enzyme is to degrade carbonic acid into water and carbon dioxide. Acetazolamide blocks this degradation and causes accumulation of carbonic acid in our body. In our kidney, the carbonic acid dissociates into hydrogen and bicarbonate ions. The bicarbonate ions are transported into the interstitium and the hydrogen exchange with the luminal sodium. In the lumen, hydrogen combines with the filter HCO3 to form H2CO3. The carbonic acid is associated into carbon dioxide and H2O again. Acetazolamide, by inhibiting the carbonic anhydrase enzyme, prevents the formation of hydrogen. Thus, hydrogen-sodium exchange is prevented and sodium is excreted along with the urine. Now we will discuss its function in our brain, where it blocks the carbonic anhydrase enzyme present in the choroid plexus cells and decreases the production of cerebrospinal fluid. It also decreases the intracranial pressure and treats the hydrocephalus. Now moving towards its function in our eyes. It blocks the carbonic anhydrase enzyme present in the ciliary body. By blocking this enzyme, it prevents the production of aqueous humor, decreasing the intraocular pressure in the eyes, used to treat glaucoma. Now let us discuss the pharmacokinetics of acetazolamide. It depends upon the concentration of carbonic anhydrase enzyme. The absorption of this drug takes place in 1 to 2 hours, given 1 to 4 times in a day, with a 90% drug excretion through the urine. The half-life of the drug is 2 to 4 hours. The adverse effects of this drug include drowsiness, mild acidosis, and kidney stones. Now, what are the therapeutic uses of these drugs? It is used to treat glaucoma, cause urinary alkalization, treats metabolic alkalosis, and used in the treatment of mountain sickness. Toxicity for acetazolamide includes hyperchloremic metabolic acidosis resulting from the chronic reduction of body's HCO3. Acidosis persists as long as the drug is continued. Another toxic effect of this drug is renal potassium wasting, which occurs due to the parietal minimal reabsorption of increased sodium presented to the collecting duct with HCO3. Other toxicities of this drug include drowsiness, CNS toxicity, and hypersensitivity reactions like rashes, fever, bone marrow suppression, and interstitial nephritis. Now, how to cope with this toxicity? No specific antidote is known. Treatment should be symptomatic and supportive. Supporting measures are required to restore serum electrolyte and pH balance. The acidosis can usually be corrected by the administration of bicarbonate ions.